Hi, welcome back to Science 1206, the motion unit. I'm Miss Ledwell, and in this video, we'll go through some examples of how to calculate velocity and time. Let's get started. First off, let's look at solving for velocity. Recall that the formula for calculating acceleration is a equals v2 minus v1 divided by delta t. We can rearrange this formula to solve for velocity. To solve for final velocity, it would be v2 equals v1 plus a times delta t. To solve for initial velocity, we can rearrange it to be v1 equals v2 minus a times delta t. Next, let's look at solving for time. The formula for calculating acceleration, a equals v2 minus v1 divided by delta t, can also be rearranged to solve for time. To solve for time, delta t equals v2 minus v1 divided by a. Let's look at some sample problems. Our first problem says, a driver sees a duck crossing the road and slams on the brakes, causing the car to accelerate at 6.25 meters per second squared west. After 2.4 seconds, the car reaches a velocity of 23 meters per second east. What was the car's initial velocity? So in this problem, we're given that the acceleration is 6.25 meters per second squared west. We're also given that the final velocity is 23 meters per second east. And we're given that the change in time is 2.4 seconds. The first step to solving any problem is figuring out the information you're given in the problem. Then you need to figure out what they are asking you to find. Here we're asked to find the initial velocity. It says, what was the car's initial velocity? Our next step then is to solve the problem using the information that we've identified. So first we'll write down the equation to solve for initial velocity, which is v1 equals v2 minus a times delta t. Next, we'll put the information we were given into the equation. So we have v1 equals 23 meters per second east minus 6.25 meters per second squared west times 2.4 seconds. Remember, order of operations means that we're doing our multiplication first. So first we'll multiply 6.25 times 2.4. Next, we're going to subtract. So we have 23 minus 15. Notice here, though, that we have different directions. One is east and one is west. So we'll need to put in positive and negative signs to represent the direction. Remember that east is positive and west is negative. When we do that, we have positive 23 meters per second minus negative 15 meters per second. If you think back to junior high math, when you subtract integers, you're going to add the opposite. So we have 23 plus 15 gives us positive 38 meters per second, or in other words, positive equates to east in this case, so 38 meters per second east. Let's try another problem. A snowmobile with an initial velocity of 5.00 meters per second east accelerates at a rate of 0.450 meters per second squared for 15.0 seconds. What is the snowmobile's final velocity? Our first step is to pick out the information we've been given. We've been given that the acceleration is 0.450 meters per second squared east. We've also been given the initial velocity, which is 5.00 meters per second east. And we've been given the change in time, which is 15.0 seconds. We've been asked to find the snowmobile's final velocity. Our first step is to write down the equation to solve for final velocity, which is v2 equals v1 plus a times delta t. Next, we're going to put the information in our given into our equation. We have v2 equals 5.00 meters per second east plus 0.450 meters per second squared east times 15.0 seconds. Remember, order of operations tells us we need to do our multiplication first. We end up with 5.00 times 6.75 meters per second east. And that gives us a final velocity of 11.75 meters per second east. Let's try one more. A ball at rest is pushed across the floor and accelerates at 1.2 meters per second squared forward. How long will it take to reach a velocity of 5 meters per second forward? So our first step is to pick out the information we're given in our problem. We're given that the acceleration is 1.2 meters per second squared forward. We're given that the initial velocity is 0 because it tells us that the ball was at rest. It's asking us about reaching a velocity of 5 meters per second forward, so that would be our final velocity. We're asked to find the time. It says, how long will it take? And that means time. So for our solution, the first thing we'll do is write down our equation to solve for time, which is delta t equals v2 minus v1 divided by a. Next, we'll put the information in our given into our equation. We have 5 meters per second forward minus 0 meters per second divided by 1.2 meters per second squared. I just want to make a note here that when you put that into your calculator, so we have 5 divided by 1.2, it'll come up as 4.1666 repeating. But remember our significant digits. In this case, we're dividing, should be the least number of significant digits that we divided, which is 1 significant digit, which means we have 1 significant digit in our answer. So our answer then is 4 seconds. Now it's time to continue to the next video. Take a quick pause to rejuvenate. Stand up, stretch out, and prepare for our next adventure in physics.